Hello everyone, this is Pankaj and I welcome you all to new day, new question series. So once again, one more question we have on the series. So let's see what we have in today's question. So today's question is saying a particle of mass one mg and charge q is lying at the midpoint of two stationary particles kept at a distance of 2m when each is carrying a same charge q. So what they have said, we have basically one particle whose mass is 1 mg, that is m, which I have written here, and charge is q, is lying at the midpoint of the two stationary particle. Total distance we have basically 2 meter. When each is carrying the same charge, this one also have charge q, this one also have charge q. If the free charge particle is displaced from its equilibrium position through a distance x, so we have displaced this charge m by a small distance x. The x is much less than basically 1 meter. The particle executes the simple harmonic motion and we want to find the angular frequency of oscillation. And one more thing which they have given, q square is equals to 10 times of c square. So based on the question, I have drawn the diagram here. As you can see here, we have two charges and this one is our third charge having mass m, q. Complete distance we had 2 meters, so 1 meter, that is d I have used here. D is equal to 1 meter. Now this q will repel this by the force F1 and this q will repel by the force of F2. So after displacement, what will happen? Initial distance d, which was, now it will become d minus x on the one side and on the other side it will become d plus x. So let's try to find the value of the force. So value of force will be basically F net. So value of force we have F net, which will be equals to F1 minus F2. So if we try to find the value of F1, value of F1 will be basically K, charges are same, Q square by distance will be D plus X. So KQ square upon D plus X square minus KQ square upon D minus X square. So we can take KQ square common. So after taking KQ square common, we can basically simplify this bracket, which is d minus x whole square upon d plus x whole square whole divided by d plus x whole square and d minus x whole square. So this is the expansion we have here. So after expanding this, let's see what we will be having. Basically I'm not writing the complete expansion, you can do the simple multiplication. After expanding this bracket, the terms which you will be having here, in the numerator we will be having minus 4 into d into x, whereas in the denominator we will be having basically d square minus x square to the power 2. Now one more thing, we know that in the question they have given basically distance x is very much less than 1 meter, so we can ignore this part, basically x square, which will be almost become equal to 0 because value is very small, and we know that when value is very small, its value answer will become almost 0. Now it will become 4 d x k q square divided by d to the power 4. Now 1d will get cancelled from here, and further after writing this part we will be having minus 4 k q square into x upon d q. Now we know that f is equals to m into a, so ma is equals to minus 4 k q square upon dq into x. Now one more thing, a will be equals to minus 4 k q square upon m times of d cube into x. Now we know that in the SHM we have basically this equation which says a is equals to minus omega square x. So on comparing we can have the value of omega square. So I'm saying this is the equation 1 and this one is basically equation number 2. So from 1 and 2, from 1 and 2, our value of omega will be equals to under root of 4 into k into q square upon m into. Now let's put the value here. We will be having omega equals to under root of 4, value of k is 9 into 10 to the power 9, value of q square they have given in the question which is 10 we have divided by mass is 1 mg which will be 10 to the power minus 6 kilogram and d is 1 meter, its cube will be 1. So after simplification 4 9s are 36, 36 out of the root it will become basically 6. We have here 10 to the power 9 plus 1 10 and this one is basically plus 6, that is 16. After coming out it will become 10 to the power 8. Now if we try to write in the form of the question which is 10 to the 5 power 5, it will be 6000 into 10 to the power 5 radian per second. This will be the final answer. Thank you.